smaller part. Bismillah Rahman. Actually, last time we were discussing the water will apply the pressure, not even the water, the any liquid or any gas as well. Apply the pressure on all sides which are in contact with that fluid perpendicularly. The pressure is applied perpendicular to the surfaces. The pressure at right or left are cancelled by the pressure at left side. So we are only left pressure at bottom and the top. So the pressure at the bottom is always larger because it is deeper. The fluid pressure increases with the depth. So pressure at the bottom, which is in upward direction, from the bottom we can apply the pressure, the force upward will be greater than the pressure, downward pressure at the top. So that upward greater pressure and upthrust is not only applied by the liquids but also the gases, right? We have discussed. So let's say if the depth of the top is H1 and depth of the bottom is H2, then the downward pressure at the top will be rho g H1, its depth is H1, and the upward pressure at the bottom will be rho g H2 as its depth is H2. So due to these two different pressure, if we have to find the net pressure, that will be bottom pressure, larger pressure minus top pressure. The bottom pressure is rho g H2 we discussed here, and pressure at top is rho g H1. The net pressure, the pressure has a formula force over area. As the net pressure is upward, so beta, the force over area here, the force will be upward. That is upthrust. You can represent it as Fu or only simply by U. Choice is yours. You can represent upthrust by U or Fu. Choice is yours. So you can take common rho gh from both of these bracket. We are left with H2 minus H1. The area divide will multiply here. If you see, as we discussed previously, this is H1 and this whole is H2. And if you subtract H2 minus H1, that will be equal to the length of this side, right? L. So H2 minus H1 can be written to as the length and multiply by area. And area is area of cross section. And when the area, this is the area of cross section, the bottom area, or you can take the area of top. Both are equal for this object. It is a cuboid object. So when area of cross section is multiplied by length, that gives the volume. So this is the formula for the upthrust. And what we are discussing is called Archimedes principle. Now there are two few things. Rho GV. It's not difficult to remember that liquid pressure is rho GH. The upthrust is rho GB. Formula is very similar है ना? H की जगह B आ गया volume. The H in liquid pressure there is rho GH. The H is replaced by V volume. That will give you the upthrust. Now, what does the rho GV mean? First of all, think of it. Rho is the density of the fluid which is applying upthrust. And V is very specific, special quantity. V is volume, but it's not simple volume of the object. Actually, it is the volume of the object which is inside the fluid. This is highlighted. It, like here you see a ball, and it's this much is inside the fluid. It is floating. Why it will be floating, by? Because the upthrust will be equal to the weight of the object. That makes it stay at this position. But now one thing we may have done maybe hundreds of times in our life, many a time, whenever we press the ball inside, the fluid downward and we leave it, then rather than staying, it rises. Why it will rise? Can you think of it? It was floating because the upthrust here was equal to weight, mg. But here it is rising, which makes it rise, the upthrust. It means in this position, the upthrust will be larger than the weight, mg, which was equal there. But what is the difference? If you see, we have shaded some, this yellow shade is the volume of object inside. Can you see here in this diagram, there was less liquid inside the fluid as compared to here is the complete liquid inside the fluid. Can you compare? So here was lesser liquid inside the fluid and here was larger volume. Sorry, here was lesser volume inside the fluid. So lesser the volume, lesser the upthrust. Here was more volume as compared to this inside. So it experiences larger wavelength, larger upthrust. So beta, this rho GV, V is the volume of object inside the fluid, right? Now, the Archimedes principle can also be explained. Actually, the real principle of Archimedes principle is this statement is this rho g we can rearrange into rho vg. So multiplying and you change the others remain same. But beta, this density multiplied by volume isn't it equal to the mass? है ना? Density is mass over volume. So density multiplied by volume is equal to mass. If we make the mass subject, that is rho v. Clear? So beta, we can write mg to be the mass. And so this formula changes into mg. And mg is weight. But this is the weight of work. What? That is important. So beta, as we know, in junior classes we have done, if we are having a container and in container there is an amount of liquid we have taken by ourselves and measuring cylinder let it is and its volume here we say it is V1, and if we submerge any object inside it, then the volume of the liquid will rise to some new level. Let's say that level is V2. So the volume of the lab object is V2 minus V1. So how much the liquid has risen? The volume of the liquid which has risen will be equal to the volume of the object inside the liquid, right? Inside the fluid. So beta, whenever we put any object inside a liquid, the liquid or fluid rises. It is displaced, we say. Displaced means which has raised. This mg is the weight of fluid which has raised. Means mg is the weight of this fluid which I am highlighting as lighter blue. Let's say this much white water was risen. So mg is the weight of that liquid. So how much the liquid will rise? It depends on the volume. Larger the volume of object and the larger amount of volume of water will rise. And the weight of this water which has risen, which has been displaced, the weight of that liquid will be equal to the upper. So beta, If we want larger thrust on any object, it should rise or displace as much water as possible. So one thing, beta, when you see the ship, mostly you see a big part of the ship outside the water, above the water. But beta, let's say sometime in your life or in movies, if the part of the ship which is inside the fluid is shown, that is even a very large part, because the larger the volume of the part of liquid inside will display the more amount of water, and the weight of that amount of water which is risen by the ship will be the upthrust acting on it. So more the volume inside, the larger, the more the water and larger will be its weight displaced, right? So larger will be the upthrust. Is it clear? So beta, that is why when a pin is needle is thrown, kept inside a fluid, it goes down and sinks down. Why it does not feel so much upthrust? Because it has very small volume. So it will displace very small amount of water, and weight of water which is displaced will be equal to the upthrust. So it will create so small upthrust that for its weight will be larger than that upthrust, and it will sink. The object which have larger weight than upthrust, they sink, right? And the materials or the object which have upthrust smaller than the weight smaller than upthrust, they rise. And material which have weight equal to upthrust, so they stay where they are, or simply they will float at the same position. Right, Veta?
Yes, sir.
Clear? Okay, now for me, if you are having these three, so I'm going to ask again, why this the same bowl when is dipped in deep inside the water will experience larger upthrust? Can you explain it?
सर क्योंकि पूरा वॉल्यूम वाटर के अंदर है.
It has larger volume inside. Now, if we have three equal ball, identical ball here, 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 which will be experiencing larger upthrust? जी बेटा.
For all of them.
Same.
सेम
Because
होगी
the
सर क्योंकि
same volume
सेम
is
वॉल्यूम.
inside. I have actually removed it. I should have removed it earlier, right?
यस
So
सर.
all of these will fail same upthrust because the same density G and B volume is same for all. Right, Beta Ji?
जी
Clear?
सर.
Okay.
यस.
Now, so upthrust is done. So let us move to the next part. Let me ask you a question. Here, let's say it is water and there is an object B and A. If it is asked which object A and B is experiencing larger water pressure, or you can say the downward pressure, A or B, what do you think?
B.
A will experience larger pressure. Why? Because the B will experience the pressure from all the sides. So the pressure at the bottom is always larger than the top. So the upward pressure is easily cancelled by, and even some upward pressure is left after subtracting the pressure at top. But for the object which is touching in contact with the bottom, any surface. It is only experiencing downward pressure. So it will be difficult to lift this one object like rather than this. And the object which is floating inside the water, that is easy to lift it up. But the object which is in contact with the bottom, it is difficult to lift that up because it experiences only downward force. If we have to lift it up, we have to cancel this downward pressure as well. Right, Peter? Now the next point, manometer. It used to be in the syllabus, 2 points, manometer and Pascal's law. Used to be in O levels, but I guess both of you have not studied it. It was not in your syllabus when you were doing your O level. So, but now we have to do that. First of all, we are going to discuss manometer. Beta manometer now, we are doing pressure. It measures the difference in pressure of two fluids. Fluid means gas or liquid. It doesn't mean pressure, it only measures the difference in pressure. And the blood pressure measuring device used by the doctor is an advanced form of it. It has a name of sphygmomanometer, means manometer added with some words, sphygmomanometer. That is our advanced type of manometer for measuring, used for measuring. If you see that in cubic form, tube, that will be again a U-shaped tube. So manometer actually is a U-shaped tube which can be filled by any liquid. Initially, what will happen if you pour the liquid into it? It could be any liquid, but if we use mercury, as mercury is very dense, so the dense material, they are having lesser volume. They cover less space. It means if we will use mercury, which the doctors do, then we will need smaller tube for that. So that is convenient for us. So it could be any liquid also. So beta, it is a U-shaped tube which is filled with some liquid. Initially, the liquid level will be same on both sides because liquid always keeps its level. But if we attach two different gases to different fluids, liquid it could be, on both sides, which are supposed to apply different pressure, then the level which was same on both sides will no more be a same level. The one side will get lower, fall, like it happened here. The other will rise. And when they are settled, they are stopped at a level, then we mark the lowest level and highest level, the new higher level and the new low level. The difference between the new lower and high levels are is said to be the H. That H, when used in the formula rho GH, will tell us the difference in pressure of these fluids. How? So first of all, tell me, beta, when we attach a gas B on this side and gas A, if the side of B gets lower and A rises, what does that mean? Which gas is applying larger pressure? What do you think?
गैस बी.
How do you know that?
सर क्योंकि लिक्विड नीचे की तरफ जा रहा है, यानी कि उस तरफ से
Very
ज्यादा
right.
प्रेशर है.
Very right. Like a balance machine होता है ना, weight machine. The if we are having a two-sided balance machine, the heavier side always lowers down, gets down. So it means here the pressure will be larger. pressure B, PB is the pressure applied by gas B, and PA is the pressure applied by gas C. So if the side B lowers down, the pressure of gas B will be larger than pressure A. And that difference in level, the new levels of both, when it gets lowered down to this level and the other gets raised to this, the difference in these two pressure levels is said to be H, and that rho G used in rho GH will tell you the difference in pressure of A and B. It only tells the difference in pressure. Now mind it one thing. If we are having same these two gases A and B and the same liquid, so if we take a narrow tube or a thicker tube, a wider tube, it will not make H remains same. So H is independent of thickness of tube. You take a narrow tube or wider, the value of H will remain same if the same liquid and same gases A and B are applied. Right, Beta ji?
Because H
Each
is
one,
only measuring difference in the level, correct?
right. And the most interestingly, if you make one side narrower and the other side thicker, like one side is this, the other side is a thicker one of tube, the H will stay the same as well. A will not change. Has no effect of the thickness of the tube. But if you change the liquid, then the H will be changed as well. It means if you will change the liquid, you will change the material. The different material will have different density. The density will be changed. How it is going to change? The larger the higher the density of a fluid will have a smaller value of H. So if you know the density or depth difference in level of first fluid as rho 1 H1, and if you change replace this one with some other fluid of density rho 2, then its depth can be used by using this formula. What is this formula? Rho 1 H1 is equal to rho 2 H2. This is only for your you can say concept. Otherwise, this is the main formula. What is that? The when we attach two different fluid on the either side of this U-shaped tube manometer, the difference in their new level H when used in rho GH will give you the difference in their pressure, right? Which side will be having larger pressure, which will be at lower level, which has new level lower than others, right? Clear? So this is the formula you have to know. Now, Pascal's law. Pascal's law is it's magical. We have said or studied Pascal already. Why? Pascal is the unit of pressure. It is kept against the name of this scientist who made this law. Why? Why he was honored, given so much respect that the unit of pressure was kept after his name? He made a law, and invention of that law did miracles, like when you go for washing of your vehicle, car, or even sometimes trucks or buses are they are given service or washed at the service stations. You may have seen many a time for washing from them from the bottom, we need to lift them, right? So cars and trucks, they are heavier ones. And do you know that how do we lift them? What is applying the force on the other side of that cylinder to lift the whole car or truck? Is air. Air can lift a vehicle. How? So beta, that miracle was done by this Pascal's law. What is Pascal's law? It is only applied for the liquids, let me tell you. So this says whenever we apply the pressure on a liquid, the liquid does not absorb the pressure, rather than it transfers the pressure equally in all directions. The question why the liquid doesn't absorb the pressure is that liquids are incompressible. What does that mean? Look, beta, you have a foam, the one we use the foam on the bed. If you fall on a foam or airbag, they are compressed, and any object which is compressed will absorb the pressure, will not transfer the pressure. So you do not get injured or hurt by striking with the ground if there is a alhamdulillah foam between you and the floor, because the foam is compressed and absorbs the pressure. But the liquids are incompressible. Technically, they are negligible compression. So we say they are incompressible. And why they are compressible? Even they are gas. Like in liquid, we have positive and negative charges between particles where the positive of one particle attaches with the attracts with the negative of other. Similar happens. But now, when even having a gap there, when we try to get them even closer, so their same charges, the positive of one repels the positive of other, negative of one repels the negative of other. That makes the particle not to come even closer if they are gaps. So in fluid liquid particles, still they are gaps, but we cannot make them get closer due to that repulsion between closer particles. So, what is Pascal's law? Let's get back to that. Whenever a pressure is exerted on a liquid, the liquid transfers, does not absorb, but transfers the pressure equally in all the directions. Right? Okay. So, how does it is applied? Let's say if we are having a pipe, cylindrical pipe with one side of area A1, other A2. It could be horizontal or one side area A1, other A2. It could be more than one areas on other side. If one side is one A1 and the other is A2, A3, A4, different. But they are be filled with the liquids. The liquid we usually use oil, not water, because water can evaporate and the oils mostly do not evaporate, so they stay as it is. So you use in car brakes the oils. That is again the hydraulic system which is based on Pascal's law. So what is so special? If you will apply a downward force on area A1, the pressure will be transferred upward on area A2 by a force F2. And if you do opposite, if you apply a downward force F2 on area A2, it will be transferred to A1 as upward force F1. So if it is downward from this side, it will be upward from other side. And if downward from the right side, it will be upward from the left side. But the pressure will be equal. What is the formula for pressure? Force over area. So F1 over A1 will be equal to F2 over A2. So this is the formula. Same you will use here. If you have area A1, A2, you apply F1 here into the right, the F2 here, because they are in the same line, F2 will also be towards right. If F2 is towards left, then F1 will also be towards left. But F1 over A1 will be equal to F2 over A2. pressure will be equal. Now, just give it a minute. Let's say when we compare this A1, area is zero point 0.5 and the force here we applied is suppose 100 Newton. If we divide them, we get an answer pressure 200. And let's say the area on the other side is 4. What should be the force here? Which will give you the again the answer same as was their ratio of 200. So that is going to be 800. It means the larger area side will always have larger force. The smaller area side will have smaller force, but the pressure will be same equally, right? So F1 over A1 is equal to F2 over A2 will be applied formula here. Where on this as well. Similarly, beta, if we are having more than one areas or cylinders on other side, and we are applying the input side is this A1 with the force F1, and here are the areas A2, A3, A4 with forces F2, F3, F4. So same formula, F1 over A1 will be equal to F2 over A2. Pressure will be same everywhere. Even F1 over A1 will be equal to F3 over A3. Even F1 over A1 will be equal to F4 over A4. Even if you have add all the forces and all the areas, total forces on the right side divided by total areas on the right side, the answer will be same, equal to F1 over A1. So beta, that is Pascal's law. And what is the application is this? If we want to increase over force, we will apply the force on smaller area, and then we will need to apply smaller force over cell, but on larger area it will be converted into a very large force. Oppositely, if we want to decrease the effect of a force, your force is to be minimized, then you will apply the force on larger area. On smaller area, it will be converted into smaller force. Effect will be reduced, but the pressure will stay the same on both sides. This is Pascal's law. The basic formula. Pascal's law is applied whenever we are having a liquid, not gases. It is especially for liquid, and with a cylinder of different area on other side, smaller and larger, smaller on one side, larger on the other side. It could be in this shape, it could be in many shapes, right? The formula is the pressure will be same on the side. Pressure is force over area. So first force over first area will be equal to second force over second area, right? Clear?